How's it, chaps, and welcome back to the Burton Builds garage. In today's episode, we are doing another teardown, a teardown of this DeWalt's DCF 880 impact wrench. This one is the 18 volt XR version. You also get a 20 volt version. It's the same drill. It just depends, well, the same impact wrench. Just depends on where in the world you are from. This is type 10, so the 10th iteration of this model. And it says 0 to 2,700 impacts per minute because it is an impact wrench. Although there is a speed rating here of 0 to 2,300 RPM because it is a multi-speed impact wrench. Now, so far I have had this for about a year and a half. And I'm pretty happy with it. It's not a super powerful impact wrench. I mean, on your big truck, you're not going to take loose really tight wheel nuts, for example. But on my small truck and on the cars we have to loosen them, it's not a problem. And also just to do general housework, general mechanical work in the garage, working on small machinery, this thing works a treat. So pretty happy with that. I do also recall watching a few videos where the newer version of this, which is the brushless version, I think it is the 887, it also has some problems. When you work it really hard, it actually starts smoking, whereas I've never experienced that problem with this unit. It does still work, so we're not tearing it down because it doesn't work. Okay, let's get into it. This one is going to be quite simple to open. You just need to remove the 8 T10 Torx fasteners, and then the clamshell will split. We may also need to remove the LED housing off the front of the casing where the anvil and the hammer is in. Okay, that should be it. All the fasteners have been removed. This one is loose. There we go. And it should open up fairly simply. There are no stickers that are joining the two halves of the clamshell, so nothing to pull off like some of the other tools that we have looked at. If I can remember, the multi-oscillating tool and some of their just the normal cordless drills, they've usually got stickers over the back. Okay, first look inside the DeWalt DCF 880. Still looking fairly clean, actually. Inside the first part of the clamshell, we can see it's fairly clean still. A little bit of grease and grime around where the openings are. Also nice to see here where the magnetic tool holder kind of bolts on either side. There's a galvanized steel nut that is cast into the plastic. And looking at the material markings might not be so easy to see because of the lighting that I've got here, but it is PA6 glass fiber reinforced 30%. So that is just a nylon-based material, glass fiber reinforced 30%. This is the same stuff that we see all of the DeWalt tools made out of. And something that I do notice here, this rubber overmolding, that's going to be a TPE, so thermoplastic elastomer, that says TPE over there. And normally these overmoldings, they've got little dovetail sort of insets over here and maybe over there and over there and over there at various places around the outside of the actual tool. Now that little dovetail or nib that helps kind of hold the overmolding to the clamshell or to the nylon. So I don't see any of that anywhere around here, which is actually a little bit worrying because over time, especially this type of tool, you're going to be holding it tight, and this rubber might work loose from the actual clamshell. Now, this is an older generation of tool. A lot of the newer stuff is all brushless, and it would be interesting to see if they've actually got in the brushless version of this tool, if they've got those little dovetail sort of nibs that run around. Otherwise, the inside of the casing looks fairly good. It seems like the mold where these were molded in had a little bit of work done over there. You can see the I don't know what you would call that. I suppose the texture on the plastic. There's a bit there, all along those edges. Same thing along this edge. Maybe that's got actually something to do with releasing it from the actual mold. Yeah, if any of you know, just let us know in the comments. Looking at the other side, quick overview. We've got the battery terminal connection plate over here. We've got a lot of the electronics down in this small black plate that runs along the bottom. Also, we've got a bit of a heat sink and the speed control over here. And this is the speed controller's switch. So looks like there's quite a bit of current that would run through the switch. So there's some of the bigger wires going this way. We've got a little ferrite ring over there, and the brush, I suppose the brush block or the brush mounting plate at the back of the motor. Of course, the motor and the hammer and anvil will be in this front section. We've also got some lighting. You can see there's some wiring running down here. Let's see if we can get it all out without damaging anything. So the first thing to come out of the unit is the casing where the hammer and anvil is. Now, instead of clicking this off this LED kind of mounting housing on the front here, instead of trying to pry it off of the housing, we're just going to unplug it over here. It's quite nice of DeWalt that they've put in a small little plug. The rest of it should just pull out fairly simply. Yep, there we go. And that's it. There's all of the electronics out in one shot. This half of the case is pretty much the same as the other half. There you can see the material markings TPE, that thermoplastic elastomer, and then PA6 nylon glass fiber reinforced 30%. So as we said earlier, most of the DeWalt tools are made of those materials. And there is the top of the housing. This is a small position switch for the forward and reverse lever that actually levers onto the trigger. The first part of the electronics we can have a look at is the battery terminal connection. So as always with all of the DeWalt products, we see nice thick spade connectors, and we've got the two main power leads going into the device, and then we've got our second two smaller leads. Again, those are probably for battery balancing, so the battery can communicate with all of the electronicals that are inside the unit, or at least that's what I think. Having a look at the back of the battery terminal connection block, we can see here there's the wiring going into the back of the actual battery plate connector. Now, I like what I see here, where we've got the wiring and it's crimped into a terminal, and then that terminal is spot welded onto the actual battery terminal. And in my view, that's going to last quite a lot longer than if this wire was just directly spot welded or soldered onto the battery's terminal. I really like this. Again, if any of you guys know any different, let us know in the comments. Looking at the two central wires, those two are likely soldered directly on to the terminals, but that's not really a problem because there's not a lot of current that goes through these, and the negative lead is also crimped into a little terminal connector, and that terminal connector is spot welded to the actual battery terminal. All of the electronics for the device, well, most of them are hidden away in this bottom section over here. Now, this bottom section, this piece of plastic, is above where the battery would go, and you can see everything is basically hidden away behind this white celastic. Now, this is basically like a hard type of silicon, and the reason they do this is to protect from moisture and dust ingress, and also to protect from vibration, because vibration is a killer of electronics. So this kind of just provides support for the entire circuit. It's also going to protect their design, because if something goes wrong inside here, it's basically almost impossible to peel this off and replace a single component. And also, quite difficult for competitors to copy the design outright. Looking at the center upstand piece, we can see here's one of the MOSFETs. Now that's used for the speed control of the device. There's one on this side and one on the other side. Both sides look pretty much identical. And this is quite nice to see, where we've got quite a big heat sink here. So dissipating a lot of heat out of there. You shouldn't have a problem with this tool, well, these MOSFETs overheating. Now, these MOSFETs are RRLB3813. If anybody is interested, you can go look up the data sheet on that. And some other interesting things that I do see here, there's quite a lot of ferrite blocks around. So there's one over here, and then there's one up towards the top of the motor, which we'll look at shortly. Looking at the upstand piece on the other side, here's the second MOSFET. Looks the same as the other side, basically, except this side has got all of the control wires going into the switch, which we'll look at shortly. Also nice to see that there is a connector that you can take loose if you need to replace certain parts. And both of the MOSFETs are riveted to the heatsink. That's quite nice. Nothing's going to rattle loose there. And then also nice to see they've used heat paste here. So the MOSFETs haven't just been plucked onto the heatsink. That should provide quite a good contact surface. As we see with most of the DeWalt products, they use DeFont switches. Now, a lot of manufacturers are going to use these switches because DeFont is one of the world's largest switch manufacturers. I mean, they've been around, I think, since the late 1970s, beginning of 1980s. I think their headquarters are in Hong Kong, if I remember correctly. But yeah, you'll see them all over the place. I think they've got a fairly good idea of how to make a good switch. The switch has got 4 main connection points where 4 of the main wires are connected to, 2 of which we can see here, the black at the bottom and the red at the top here. So it looks like these wires are spot welded, spot soldered onto the switch terminals. Again, I'm not the biggest fan of this type of thing. I wish they could have done the same as what they did at the bottom, where they used a crimped lug and then they spot welded the lug onto the switch. I do like what I see when I look at the front of the switch. We've got the trigger over here and the actual switching part is inside this plastic bit. And then we've got a small push rod. And if you look very closely into that lighter material there, that lighter material is actually a wiper, which is providing a bit of a seal so that it kind of limits the ingress of maybe moisture and dust into the working part of the switch. Not a lot of new tools have got this. It would have been nice to see, say, a bellows and an O-ring, but this is really, really a welcome sight. At the top of the switch, we can see the forward and reverse lever. Now, this thing feels very plasticky and not very sturdy at all. Although I haven't had any problems with it. I'm not sure any of you guys have had any problems with it. If you have, leave us a comment. But yeah, it just it doesn't feel like super quality. Above the switch, we've got the brush block. Now this is a replaceable item. This block is normally mounted at the back side of the motor and fairly easy to replace. You just pull off these flat spade connectors, those 2, and you can replace that. Underneath here we can also see a ferrite core or block or choke. It's got various different names, but generally these things are used to suppress high frequencies to limit the RF interference that we might get. And I'm sure there's a lot of switching going on from these MOSFETs down below, which this is going to take care of. Well, this one and the one that we saw earlier at the bottom of the circuit. Nice to see a ball bearing at the tail end of the motor. There is also a ball bearing at the front end, which we'll look at shortly. And also nice to see this epoxy type of material that is cast over the joint where the windings join onto the commutator. Now, the reason they do this is because there's a lot of expansion and contraction. And what can happen is these windings can actually crack off the commutator. And when they put this type of coating underneath or over it, it kind of limits that happening. The gear on the front of the motor looks like a sintered metal piece, and it has been machined over here because this part runs into the bearing that supports the front end of the armature. Last but not least, we've got the business end where the hammer and anvil are situated. And at the front here, we've got this little plastic housing that holds the 3 LEDs that provides a little bit of light. Fairly easy to remove this, just a slight rotation in a clockwise direction, and it pulls right off. A closer look at the front housing doesn't reveal very much, just a small circular circuit board that supports the 3 LEDs in the housing. Opening up the back of the gearbox is fairly simple. You just pull off this plastic piece at the back, so like a plastic housing, PA6 glass fiber reinforced 30%, and that will reveal the gearbox. To gain access to the inside of the gearbox, you just push on the front end of this shaft. You've got to give it quite a firm push, and then everything will slide out. So we've got the small retaining ring, and that's part of the ring gear. So we've got just a single stage gearbox reduction. And there we've got the hammer and anvil. The back side of the gearbox has got 2 bearings, an internal and an external bearing. So the internal bearing is there to support the motor's shaft, and the external bearing, this bigger one, is there to support the actual shaft, hammer and anvil section that moves through the tool. This is just a single stage reduction gearbox. So we've got the sun gear, of course, on the armature of the motor, the ring gear over here, and then just 2 planet gears providing reduction. We've also got quite a nice beefy spring that is pressing the gearbox against, or it's providing a spring pressure, keeping the hammer section forward. So the way this works, the hammer hits against the anvil. The anvil is this forward section over there. And what ends up happening is you get rotation, the hammer hits the anvil, and then eventually the hammer section bounces back and then past the anvil until its next rotation or until its next hammer point, where it hammers it around slightly more and then bounces behind the anvil again and rotates again, bounces, hammers it a little bit more, and so the cycle continues. And that's what kind of gives you your hammer or impact action in a rotary motion. Not much to see in the casing other than in the front end there's a nice needle roller bearing, so quite big, and a little bit of grease. The casing seems like it is a sintered aluminium type of material with some machined ends at the front and the rear, and fairly thin here at the back, and quite thick, quite a lot thicker here at the front. And we can see the little bearing popping out there again. Okay, that's pretty much it. So my final thoughts on the impact wrench, now that it's together and working again, is that it's a fairly well-built unit. I hope you saw what you came here to see, and if you have any comments on the specific internals of this device, maybe you've had yours for a couple of years and you can actually see what exactly wears. I mean, this one is not very old at all, but it's nice just to share your story with the other users. Chaps, that's it. Please like the video, give it a thumbs up if you liked it, subscribe if you haven't subscribed already, and yeah, I guess we'll see you in the next one. Cheers.